All right, so we are learning the quotient rule today, and the quotient rule is a way for finding the derivative of a quotient. So what happens is if you have functions and they are dividing another function, then you have to apply the quotient rule. And essentially what the quotient rule says is that we have Hody Hi and Heidi Ho, and we're going to use them together as we go through these problems. So the quotient rule in its formal definition is f of x over g of x. So f of x over g of x, where f is the high function. It is the function on top. So you're going to hear me talk about the top function versus the bottom function. So f of x is high. G of x is ho or low. You can also call it low. But I'm going to, because I learned it as Heidi Ho, I'll probably say ho, but if you want to call it low. So I always joke, this is the lesson that is the Snow White fairy tale. Hi ho, hi ho, hi ho. It's off to go. You're learning the quotient rule today and use it every day. So it's hi ho. So then the quotient rule is ho d high, where it's denominator times derivative, hence the d, the top, high, so ho d high, minus high d ho, top times derivative of the bottom, all over ho ho ho. So g of x squared. So in your head, you'll start going Hody Hi minus Heidi Ho all over ho ho. And that's the biggest thing, or the biggest mistake I see students make, is the product rule is a plus. So product positive plus, quotient is a minus. So I always tell kids, think about like when you're subtracting or dividing variables, it's top minus bottom, right? Quotient rule is the subtraction. So Hody Hi minus Heidi Ho all over ho ho. And then at that point, it's like the definition of the derivative. You do the calc, you clean it up with algebra. So find f prime of x. So f prime of x equals ho, so x squared plus 1, d high, derivative of x squared minus 1 is 2x, minus high, so the top, d ho, derivative of the bottom, all over ho ho, or the bottom squared. Distribute, simplify. So you have 2x cubed plus 2x minus 2x cubed plus 2x all over, and you have to write it every time. X squared plus 1 squared. The 2x cubed cancel. 2x plus 2x is 4x over x squared plus 1 squared. Did it look worse than it was? Like, I feel like the formula looks harder than they are. Next, you're done. Same thing. Hi ho, hi ho. It's off to calc you go. So Hody Hi minus high d ho all over, ho ho. Multiply, simplify. This is not like the definition of the derivative where a ton of stuff canceled each other. You just have very long, messy answers. So we got negative x to the fourth minus 2x cubed plus 6x squared plus 12x plus 6. Anytime you have a square root, you want to think of it as writing it as the 1/2 power. You also want to look at the denominator. And yes, this is a function over a function. But what's different about example 3 than we had in examples 1 and 2? Example 3, my denominator is what? It is a monomial. It is a single term. If you have a monomial, you again, like the product rule, have a choice. You can divide each term of the top and not do the quotient rule. So if you have a single term in your denominator, you can divide it out among every term in the top and not have to do the quotient rule. Or you can do the quotient rule. Both, again, it's like the product rule, right? You can FOIL then derive, or you can do the product rule. Same with this. You could do the quotient rule, or you can divide the denominator out and then take your derivative. So do we want to see a side-by-side of both, like I did with the product rule? Anybody start the quotient rule yet? All right, well, let's do the quotient rule, and then we'll do a side-by-side. Oopsies. Good. We got 1/2 x minus 3x.
if you had simplified from the beginning,
you'd have had x over x to the 1/2 minus 3x to the 3/2 over x to the 1/2. So that again would have become x to the 1/2 minus 3x. Because you take top minus bottom, so 1 minus 1/2 was 1/2. 3/2 minus 1/2 was 1. So then you would have taken the derivative of that, and you'd have had f prime x equals 1/2 x. Oh, to the negative 1/2. Did I drop that? Negative. All over x. Sorry, all over x. I did. And then you'd have 1/2 x to the negative 1/2 minus 3, which ultimately gave you 1 over 2 square roots of x minus 3. And that's what you got with the blue as well, if you had, not forgot right here, all over x, like I did. Again, I think the red is easier. So if you have a single term in the denominator, it is easier to divide it out and then derive than it is to do the quotient rule. And that's like the moral of this example. It's like the product rule, and sometimes it's easier to multiply first.
I have a question.
Yeah.
So in the last one, when the square root moves into the bottom, it was positive before.
All over x though. So 1/2 minus 1 is negative 1/2. Yes. So it's not that it magically like moved to the bottom. It's because I simplified the all over x. Just so that the blue and the red matched each other. You could have left it kind of like here, but I wanted my blue and my red to match. So I knew I needed to simplify my variables.
Okay.
Yeah.
Because I just like left it as like
this part
square root of x over 2 minus 6x.
That's fine. Yeah. I'm pretty sure this find the equation of the tangent line at 1, -2 is supposed to be on the page before. And like your spacing got goofed up. Because if you plug in 1, I'm going to think you get -2. 1 minus 3 is -2 all over 1. Yeah. So using that slope right there, find the equation of your tangent line. So I find the equation of the tangent line at f prime of 1. We're going to plug 1 into that. So you get 1/2 minus 3. So you get -2.5 or -5/2. And then at that point, that represents the slope. So the equation of the tangent line is y minus a -2, -5/2, x minus 1, y equals 5/2 x minus a minus. Therefore, it is a positive 5/2 minus 2. So y equals -5/2 x minus, plus 1/2. Sorry about that. I have too many spaces on your page. All right, I really like these. They always pop up on the AP test. Sometimes as multiple choice, sometimes as part of a free response. So all it's doing is testing your knowledge of our rules. So it's f times g prime of 5. So am I using power, product, or quotient?
Product.
Product. Because f times g. So the product rule says the first, so that's f of 5, times derivative of the second, so that's g prime 5, plus the second, so g of 5, times derivative of the first, f prime 5. So first times derivative of the second plus second times derivative of the first at the particular point, 5. Then you just go up. It might be given to you as like function notation like this. Could also be given to you in a table. Might also be given to you in a table. All we're going to do is plug in chug. F of 5 is 1. G prime 5 is 2. G of 5 is -3. And f prime of 5 is 6. So 1 times 2 is 2. 3 times 6 is -18. 2 minus 18 is -16. I knew it.
I just didn't type them for myself on the next slide. Like a dummy.
All right, f divides g prime of 5. So do we think that f divides g and g divides f are going to have the same value? Are they going to have reciprocal values? So that is kind of like the mission, like we want to compare, okay, what's f prime of f divided by g prime of 5 and g divided by f prime of 5. Just comparing them, seeing if they have any sort of relationship. So now we need the quotient rule. So the quotient rule again is high ho or high low. So it's ho d high. So in this case, that's g of 5 times derivative of f. So f prime 5 minus f of 5 I dho. So that's derivative of g at 5 all over g of 5 squared. So it is essentially the quotient rule, but now everywhere you had an x, you have a 5, and then we plug in our numbers. So -18 minus 2 all over -3 squared. So you got -20 over 9, which was -20 over 9. And then g divides 5 is going to be the reverse of all of that. So this is going to be f of 5 times g prime 5 minus g of 5 times f prime 5, because again, ho d high minus I d ho all over the denominator squared. Now remember, when you're squaring the denominator you're plugging in is the original, not the derivative. So the denominator is the original squared, not the derivative. F of 5 is 1, g prime of 5 is 2, minus g of 5, which is -3, f prime of 5 is 6, all over, thank goodness, 1 squared. So now I have 2 plus 18 over 1, or 20. So no set relationship no reciprocal properties, just sort of two very different answers. How do we feel about quotient rule? How do we feel about all our rules? How much do we like this more than the definition of the derivative?
I like the definition of the derivative better than the product rule.
Really? Okay.
I like the power rule and I like the quotient rule. The product one. How do I go back to recording?